Okay, so now for the past few days, we have drawn some functions like these guys, and we say that there are something called asymptotes, and asymptotes are things that the graphs would lean towards to. And I hope this kind of graph would not be too boring to you. Okay. Now for this paper that you are creating, I want to make sure that you can use it as a little guidance, okay, as you are trying to obtain the features of the graphs. And so let's start with our first item. Now, the first item, it's, let's think about our x-intercept, okay? So to find our x-intercept, I'm gonna put this as action. So what you would do and the reason, okay? So I don't want you to just know what to do. I also want you to know the reason behind the action. So for x-intercept, how do you find x-intercept? We put 0 into the y. And the reason is? Well, this is x-intercept, right? Okay, so we say y value is always 0 for an x-intercept, okay? So I want to make sure that you are not just knowing what to do. I want you to know the reason. And I need you to hold your standard high, that you're not just telling yourself or telling people what to do, but you are explaining to yourself why you need to do this. If you don't understand the why, I'm pretty sure that you will get very confused. But once you take that one extra step to know the why, it will get a lot easier. And this is something we have been doing for years, if you recognize it. And the next one is the y-intercept. And we say, if we want to find a y-intercept, what do? We put 0 into the x. And because all the y-intercepts, okay, the x value, it's always 0 for a y-intercept. So far, we are not doing anything new so far at this point, okay? Whether you do a linear equation, quadratic, cubic, cube root, square root, anything, this is gonna hold true because, well, that's what we do, that's what it is, all right? Now, something more recent is that we asked a question. What is restriction? How do you find the restriction? Remember last week stuff? On a test, we say, oh, what are the restrictions? How do you find the restrictions? Yeah, so we say, oh, we set the denominator to 0, okay, to find the restrictions. Okay, and because the reason is if the denominator is 0, what happens if the denominator is 0? It's undefined. The whole fraction is undefined. Okay, and we don't want that. Okay, so if the denominator is 0, the whole fraction is undefined, or your calculator will call it error. So we don't want it. Okay, and if you understand how to find restriction, then congratulations. This is also the way to find your vertical asymptote. Okay, so that's why for the past 2 days, when we were doing all these vertical asymptotes, we look at the denominator and we'd say, oh, can you look at the denominator? What's the restriction? And then based on the restriction, then you also know the vertical asymptote. Yes.
Okay, so let's say the vertical asymptote. It must be one number, right?
Okay, yes.
So how do you know which is the other number?
Okay, all right, very good. So let's just say we have x minus 2. Okay, so if we go back to last week, we'll say, hey guys, what's the restriction of this fraction? And you say 2, right? So we would say, oh, x cannot be 2. So a restriction would be x cannot equal to 2. And now to illustrate graphically how this restriction is playing a role for the entire graph, then we say, oh, what is the vertical asymptote? Now make sure that you would say x equals to 2, and that would illustrate the line at x equals to 2. Okay, don't touch it. It's not going to happen. Don't even dream of passing through this line. Okay, so far so good. Now, if this is good, and let me go on, and we talk about one next thing. I'm going to use a blue color instead. Actually, I'm going to use a purple color instead. So the next one is called the horizontal asymptote. Okay. So we talk about vertical asymptote, and now we talk about horizontal asymptote. I don't want to use red color. Now I use red for vertical asymptotes because I want you to think about this as like a little red line. You don't want to touch it. You don't want to cross it. But horizontal asymptote. Now I want you to take a quick look here. Now, if I do a quick search of horizontal asymptote, so you will see something like this. Okay, something that we have been doing. Okay, that's normal. And now this one is it's also a good one. And if you look at this picture, and let's ask the question: could the graph touch across the horizontal asymptote?
Well, since there's multiple.
And we say, hey, look at here, look at right around between 0 and -1. No, that's the vertical asymptote. So, and this is the common misconception about the word asymptote. Okay, so that's why on day 1, if you remember on day 1, I said asymptote is simply a line that the graph approaches to. I did not put a condition on whether it could or could not touch. When we talk about vertical asymptote, that is indeed vertical asymptote specifically, that is a line that the graph cannot touch. That's for vertical asymptote only. But for horizontal asymptote, it could cross, but I just want you to see how it could cross. But what you also see here is that as you go to the ends of the x-axis, can you see how the graph is approaching it? So I'm going to show you how to tell. Okay, so for horizontal asymptote, okay, so what to do is observe the largest degree or power of the numerator and denominator. Okay, go ahead. Observe the largest degree of power of the numerator and denominator. So you have 3 possible situations. Situation number 1, okay, is this. it's like you have x squared on top, and you have x cubed in the bottom. So in this case, we will say denominators degree, it's higher. Okay, so if the denominator's degree is higher, then we'll say the horizontal asymptote is equal to y equals to 0. Okay, I'm going to give you some time to write it down. Okay. I said get a piece of paper and write it down. Okay, so if you have x squared over x cubed, this kind of situation, then where the denominator's degree is higher, then the horizontal asymptote is y equal to 0. But why? What's the reason? Okay, the reason is this. So think of n becoming infinity. Okay, so this is the reason of think of x, not n. Think of x becoming infinity. Okay, so we will ask the question: if x becomes a very big number, okay, so what would happen? So we say, well, if you think about it, x squared over x cubed is essentially 1 over x, right? And think, what is 1 over a huge number? Is it a big number or a small number? If it's 1 divided by a huge number, it's going to be a very tiny number, which is so tiny that it's close to 0. And if you say, wait, hold on, I don't get what you're saying. What do you mean by 1 divided by a huge number? Then I would say to you, well, how about this? How about use a calculator and just say, well, 1 over 2. Well, 1 over 2, you get 0.5, right? 1 over 10, you get 0.1. 1 over 100, you get 0.01. 1 over 100,000. Okay, as you can see here, as the denominator gets bigger, how would you describe the fraction? I mean, how would you describe the value of the fraction? It gets smaller. So if you say, well, I'm going to put down this, okay, so you get something what you will see in chemistry with the scientific notation 1 times 10 to the negative 11, meaning that there is 10 zeros following the decimal point. Really small. So that's why we make the comment of, well, if you think about this, if you have x becoming infinity, the huge number, then you essentially have 0. So that's why you have this picture right here. Okay, so we're saying, hey, can you take a look over here when x going all the way to the right? Okay, all the way to the right, which becomes a very big number. Hey, what's the value over there? What's the value of y? We'd say it's getting closer to 0. Okay, and the same is true if we go to the opposite direction for the negative infinity. So now we are not going to do complicated stuff like this, but I just want to show you that there are some complicated stuff that you will see in the future if you take pre-calc next year. Okay, and I also want you to see that horizontal asymptote could be crossed. Vertical asymptote cannot be crossed. Okay, so I don't want you to have a blanket understanding of asymptote, which is something that you cannot cross ever in your life. Well, that's not true. Okay, so that's what happens when you have a denominator's degree is higher. Now let's go for the second example. The second example, could be something like this: 2x squared plus x minus 3 over 4x squared minus 3x plus 1, something like this. And you observe the largest degree, the largest power on both numerator and the denominator. And we can say, well, in this case, both have the same power or same degree. There's an arrow. Arrow. Minus 3 here. And you're saying this? 3x. Okay. So we're looking at the power. We say, well, if you look at the degree, this is 2 and this is 2. They are the same. So we will say the horizontal asymptote is y equals to the ratio of the leading coefficients. So in this case, it will be just 1/2. Okay. And the idea behind this is that now let's see if you can think about this conceptually. If you have x being infinity, does the minus 3 matter? Okay, it's just like if you are very rich, would losing $3 gonna affect your life? Not really. Well, I mean, we should care about all the wealth, but in the grand scheme of things, it doesn't really matter much. So comparatively speaking, well, the minus 3 doesn't matter when you have an infinity square. If you have infinity square, well, infinity times infinity, that's a huge number. So the infinity doesn't matter. So all we care is only the largest power. And we say, well, let's take a look. Let's take a look at this and we say, they're the same. So we just use the same. Well, we just basically cross out the x squared. So if you have 2x squared over 4x squared, so x squared and x squared cancels out. And you have 2 over 4, and you reduce it to 1/2. That's the idea behind it. All right. So we're going to explore only these two situations with horizontal asymptotes. So if the denominator is greater, then horizontal asymptote will be y equal to 0 because the denominator it's going to be huge. So 1 over infinity, it's 0. If they have the same power, we just take the leading coefficient. Okay. So now let's take a look at the first page of your notes now. So hopefully, after going through these, you have a better idea on what to do. So it's that first concept, vertical asymptote. We say if you look at the organized chart, we say, well, vertical asymptote is basically asking for the restriction. So we call this a vertical line thing, vertical asymptote, and for this particular one, the vertical asymptote is. Use a red color. So we say, well, what's the restriction here? 2. So the vertical asymptote will be x equals to 2. Make sure you write down the whole thing. X equals to 2. Do not just write down 2 because it's a line. If you just write down 2, that will be incorrect. Okay. You have to write down the line. You have to express it as a line. Okay. So this vertical dashed line, it's called the vertical asymptote. For what? Oh yeah, you have to write the whole thing. Yes. So now, if you look at this particular example, we say, oh, what's the vertical asymptote for this fraction right here? And basically, we're asking the question, hey, you know what's the restriction here? We say the restrictions are x cannot be 0 and -3. So therefore, the vertical asymptotes are x equals to 0 and x equals to -3. Okay. So make sure you understand the context because I understand how it could be confusing that, On one side, we say x cannot be 0, x cannot be -3. On the other side, you say, oh, x equals 0, x equals to -3. So make sure you understand the context. When we say about the restrictions, we say, oh, x cannot be 0 and -3. And then on the graph, we're going to use, if we can use a color pen, and we say, oh yeah, on the graph, we are going to draw an asymptote at x equals 0 and x equals to 3, just to tell people that don't graph anything to cross this line. Okay, so contextual. Make sure you understand the context of how and why we're drawing these graphs. All right, so now how about this? Now for the second concept, we look at these functions. So we are saying, all right, now horizontal asymptote, something that we have just talked about. We say observe the largest degree. Okay, so let me use the purple color in this case. Observe the largest degree in both numerator and denominator. Okay, so we say, all right, let's look at this case. First one, 2 over x minus 4. 2 over x minus 4. And we say, oh, this one, this is x to the first power. This is x to the 0th power. You don't see any x's. So we say the denominator's degree is higher. So therefore, the horizontal asymptote is going to be at y equals 0. Okay, so again, think 1 over infinity, it's approximately 0. Because as x gets bigger and bigger, okay, if you go all the way to the right, you can foresee that the denominator is going to be gigantic while the numerator is going to stay at 2. Okay, so that's how you have it. And so that's the horizontal asymptote. Now, for the fraction next to it here, so we say, well, in this case, they both have the same degree. So we look at the leading coefficient. Okay, so we say, oh, this is just x over x. So x over x is equal to 1. So we say y equals to 1 in this case. Okay, so we just look at the very first term, okay, the largest term basically. And for the one that's on the right, y is 2x minus 1 plus 2. So the minus 1 and plus 2 doesn't matter. So 2x over x is equal to 2. So we say y equals to 2 in this case. Now, it takes time to sink in this horizontal asymptote concept. If you could, I really want you to use the idea of infinity to understand what's going on so that it's more long lasting. I sincerely do not want you to just, memorize the steps and then just do the thing. So let's go to the back page. Okay, so let's do a few things here. All right, now, so let's walk through number 1 together. So again, we have the xy intercepts. Okay, for x-intercept, what do we know for sure? We know that the y value is always 0. For x-intercept, we know the x value is always 0. So I would say let's go ahead and find out the y-intercept first. That's always an easier thing to do. There's no particular order, by the way, but it's something that I would like to do because it's easier. So when I put in 0 into the x, I've got -1/2. Okay, so -1/2. So I'm going to put a point right here. Okay, -1/2. Okay. Now that we have the what about the x-intercept? Well, x-intercept is when you have the y equal to 0. Okay. Now, yesterday I asked you to write down one thing. Remember that if you have to find out a fraction, okay, when the fraction equal to 0, that means the numerator must be 0. Okay. But now, in this case, in order to be 0, the numerator has to be 0. Well, can 0 equal to 2?
No.
Nope. So we actually we say, whoop, too bad. We actually don't have a x-intercept because 0 can never be 2. Okay. You can just you cross it out so that you can tell yourself how it is not possible to have an x-intercept because the numerator can never be 0. Now for the vertical asymptote, looking at the restriction, we say, yeah, we're going to draw a line at 4. Okay, so you can also use what we did for the past 2 days and say, oh yeah, it's shifted to the right 4 units. That works too. Okay. Now. Mm-hmm. Huh? Well, these fractions altogether. So so horizontal asymptote, in this case, we'll say it is y equals 0 because, now for the moment, I would like you to write the because the degree in the denominator is larger. Okay, you have x to the first power in the denominator and you don't have any x. So we assume that it's x to the 0th power. So so that's why horizontal asymptote is y equal to 0. So we well, you can tell based on the power, and the idea is that if the power in the denominator is greater, that means if we go all the way to the right, well, x will become a gigantic number. So 2 over a gigantic number is what? It's practically 0. So we would plot the points here. Okay. That's how you know. That's how you know. And this is also the very first topic that you will encounter when you go to pre-calculus. So if you can do this well here in Algebra 2, it's going to save you a lot of work next year. Okay. So next one. Oh, no, the domain. I forgot to write the domain. Now the domain. So since you know the vertical asymptote, since you know the restriction, then we can write down the domain. The domain is going to be from -infinity to 4. And from 4 to infinity. So x values could be everything but 4. Because if x is 4, the denominator becomes 0, and it becomes, the fraction will become undefined. Yes. You could. That's way more writing than you need to do. And also in pre-calc and calculus, this is actually what you would use to express your domain. So I just want to get you all used to this kind of notation. Okay, the inequality notation, sometimes it works, sometimes it's kind of lengthy. So we just don't like that. Okay, so we use interval notation for the near future. All right. So for number two, okay, so let's go ahead and, ooh, what's the restriction here? Since we can just take a quick glance at it. The restriction, it's x cannot be 0. So that means our vertical asymptote is x equal to 0. Okay, again, there's no particular order on which one to find out first. Okay, you can find out any one that you like, but it's just something that you ask yourself, do you know what to do? Do you know what to do? So now if we know the vertical asymptote being at the y-axis, could there be a y-intercept? It's impossible because the graph would never ever be able to touch the vertical asymptote. So therefore, it is impossible to have a y-intercept. Okay, so we can kind of save your work. And well, if you did not see it, then you can still think about, I know finding y-intercept is to put 0 into our x value. And once you think about putting 0 into x, there's 0 in the denominator. And you know, it's not going to turn out right. It's going to be undefined. It's bad. Okay. Well, what about x-intercept? X-intercept is about getting the y equal to 0. Okay. And like we said yesterday, if you have a fraction that's equal to 0, if you have a fraction equal to 0, that means the numerator must be 0. Okay. Or the other way to think about it is that if you multiply both sides by x, then x got canceled out, but the left is still 0. So you have 0 is equal to 2x minus 5. So what is x? 5 over 2. Well, 5 over 2. Okay. So we say, all right, so the x-intercept, it's 5 over 2 or 2.5 comma 0. So so x-intercept is 2.5 comma 0 right here. Okay, you can make a point. 2.5. You can leave it as fraction, yeah. Fraction is always good. Oh, you have to. You have to. All right, so far we have all these. And I think we can write the domain too, since we have the vertical asymptote. The domain will be from -infinity to 0, and from 0 to infinity. So everything but 0, it's our domain. And the horizontal asymptote is, well, in this case, you can see that the numerator and the denominator, they have the same power. So we just go ahead and take the leading coefficient, or think about 2x over 1, 2x over 1x. It's equal to 2. Okay. And that's because both numerator and denominator have the same degree or same power. Okay, make sure you write down the reason, okay, to justify at this moment, at the early stage. Okay, in the future, we just need you to write down the equation for the asymptotes, but for the moment, I would like you to write it down so that you have a little reference for yourself. Okay. So let's go ahead and draw this horizontal asymptote. So purple line right here. And then I forgot I erased a point somehow. All right, now. So How are we going to make this graph in this case? How are we going to make this graph in this case? Okay. Now let's see if you can figure out the logic. To the left of the vertical asymptote. To the left of vertical asymptote. Okay. To the left of vertical asymptote. Now we have to think about this. Do we graph above the horizontal asymptote or below the horizontal asymptote? Given that there is no x-intercept to the left-hand side of the vertical asymptote. So now let me just go ahead and put both situations in play. Which one makes sense? The top or the bottom? Given that we do not have any x-intercept on the left. Only the top makes sense because we do not have the asymptote here. So here, only the bottom makes sense because it has to cross over the x-axis here.